When working with quadratic equations, one of the key features that you will likely want to know about is the y-intercept. Now, when an equation is written in vertex form, like the one shown here is, you can't easily identify the y-intercept. So one other form that sometimes we write it in so that we can see the y-intercept easily is standard form. So standard form is y equals ax squared plus bx plus c. And a couple of things that standard form tells us is it tells us the concavity. In other words, if the graph is concave up or concave down. Now, it's concave up if the value of a, or the leading coefficient, is positive or greater than 0. So what that looks like is if you have, for example, that a is 2, then your graph is going to open up. So that's what concave up looks like. And if the value in front of the x squared, or the leading coefficient, is negative, it's going to be concave down. And when it's concave down, what it looks like is it's going to open down. Sometimes we think of it as happy face for concave up and sad face for concave down. The other thing that standard form tells you is it will tell you the y-intercept. Now the y-intercept on a graph is where x is equal to 0. So if we look at any kind of equation, if I were to graph it like this, the coordinates of this point right here, since we haven't gone right or left any from the origin, we know that the x-coordinate has to be 0. So since the x-coordinate is 0, we just have to go up and find the y-coordinate on the y-axis. X-axis, y-axis. And so it's just going to be some value y. Now, when we look at standard form, if I were to substitute in 0 for the x here and the x here, both of those terms would become 0, and we would be left with c as the y-intercept. So that's how we end up with the y-intercept being 0, c. So now let's look at the equation that we were given. We were given the equation in vertex form, and we need to write it in standard form. So if we want to write it in standard form, one method that we can use to do that is using an area model. So here's our favorite area model. And what we can do in order to get that filled in is we first have to simplify what's in this squared right here. So sometimes students have trouble thinking about, well, what do I do first when I start to solve an equation? Well, whenever you're wondering what to do first, I like to go back and think about our old friend, the order of operations. So we look at PEMDAS, or parentheses, exponents, multiplication and division, addition and subtraction. So we're just trying to simplify this. So if we start at the top with parentheses, well, there's nothing we can do in the parentheses right here because those are not like terms. So the next option we have is to use the exponents. So I need to simplify the exponents right here. Since that's squared, I know that I can write x minus 1 squared as x minus 1 times x minus 1. So that's what I'm going to use for the two side lengths of my area model. So I'm going to write x minus 1 and x minus 1. And now we're going to fill in the area of the four smaller squares, or I should say possibly rectangles. For this one, when we start to fill it in, we get, in this box right here, x times x is x squared. In the box to the right, -1 times x is -1x. In the lower left box, we have x times -1, which is -1x. And then in the bottom right-hand corner, we have -1 times -1, which is +1. So now I can show my x squared in a different way by adding together the four pieces. So when we add them together, we get x squared plus -1x plus -1x plus 1. Now hopefully you notice that we have like terms here in the middle, and the like terms in the middle can be combined. And so now we have x squared plus -1x plus -1x is -2x plus 1. And if you prefer to write it as x squared minus 2x plus 1, that's fine too. So now that we have the exponents taken care of, so if we go down our order of operations checklist, we didn't have any parentheses to do. We took care of the exponents. So now we have to deal with this multiplication and division. So going back to our original equation up here, we see that we have y equals 5x minus 1 squared plus 17. Well, we just figured out the x plus 1 squared, so I'm going to substitute that in. So I have 5, and then this becomes our value from over here, which is x squared minus 2x plus 1, and then we still have the plus 17 on the end. So we need to take care of the multiplication, which is this 5 out front. So what we need to do is to distribute the 5 to the 3 terms inside the parentheses. When we do that, we get 5 times x squared is 5x squared. 5 times negative 2x is negative 10x, or minus 10x. And 5 times 1 is 5. Now we still have that plus 17 on the end, so we're just going to rewrite it. So now going back to our order of operations, we've taken care of any multiplication and division. So now we have to do any addition and subtraction that we can. So we need to look for any like terms. In our last step of the equation down here, the only like terms that we have are the 5 and the 17. So when we add 5 and 17, we are going to get 22. So now we have 5x squared minus 10x plus 22. So what that tells me, going back to our standard form over here, and the last statement we have, which is that the y-intercept is 0c, I can see right here that that's going to be the y-coordinate of my y-intercept. So the y-intercept is, we're going to go, like we saw here, over 0, but we're going to go up 22. So my y-intercept is at 0, 22. Now, again, going back over to the information we gave before, we can also mention the concavity. And the concavity of our equation, looking at either the original one up here or looking at the one down here, we can see that our leading coefficient is a 5. So our concavity, we know that it is concave up because that leading coefficient, or the a value here, is a positive value. So then it's going to be concave up. So that's how you identify the coordinates of the y-intercept when an equation is given in vertex form.